In this lesson, we're looking at solving a 3 by 3 system of equations, and that means that we have 3 equations and 3 unknown values. And in this case, we'll consider them to be x, y, and z. We won't actually be graphing 3D systems of equations in this course, but this is what the equations would be like. And we're just going to look at algebraic solutions to 3 by 3 systems. This is going to help us learn some skills whereby we can solve more types of equations, more types of systems of equations than the 2 by 2 systems with just an x and y as we were doing earlier. So the first question is -5, -4, -22 the solution to this system? And by this system, I mean these 3 equations. So before we even learn to find the solution, let's figure out how to check whether a solution that we have is the solution to the system. Remember that by definition, the solution has to be true for all of the equations. So all we do is one at a time check our 3 equations. If this point or if these values satisfy all 3 equations, it is the solution. If it doesn't satisfy even one of them, it's no longer a solution. So let's start with number 1, and we'll substitute the x, y, and z in. So 4 times -5 plus 3 times -4 minus -22 equals -10. So that's -20 minus 12 plus 22. So that will be -32 plus 22, so that's -10 equals -10. So the point does satisfy or make true the first equation. So let's take a look at the second equation now. We've got 2 times -5 minus 3 times -4 plus 7 times -22 equals -10. So on the left I've got -10 plus 12, that's minus 150, 7 times 2 is 12, 14 plus 140, so 154 equals -10, and we can see pretty quickly that that's going to give us -164 plus 12, -152. Whatever it comes to, it's not equal. So as soon as we see, and my apologies, that should have been -8 because I switched to the right side of the first equation. So we're looking at the second equation, 2x minus 3y plus 7z equals -8. And I could see that those still are not equal. So this is not a solution to the system. We don't even need to check the third equation because whether that point falls on that plane or not, it's not going to be a solution because it doesn't work for the second one. So now let's look at solving a linear system, a 3 by 3 system. The only method that we use for that is the elimination method, okay? So I'm going to start with 6x plus 3y minus z equals -15. That's my first equation. My second equation is 2x minus 5y minus 2z equals 3. And my third equation is 4x plus y plus z equals 3. So to do the elimination, you need to do it in stages, and so you need to choose one variable first that you're going to eliminate. And you need to eliminate it twice using a different pair of equations each time. So when I look at For example, equation 3, I notice that I have a plus z, and in equation 1 I have a minus z. So it's very easy for me to eliminate z using equation 1 and equation 3. So I'm going to just here below equation 1 write plus 3. So I have 4x plus y plus z equals 3. So I'm adding those two equations together, and I have 10x plus 4y equals negative 12. So now I have an equation with only two variables in it. If I look at, since I eliminated z from this pair, I also need to eliminate z using a different pair. Now, I have to use equation 2 because it hasn't been used yet, and I could use either 1 or 3 with it. And what I'll do is I'll use 3 again, but I'll multiply equation 3 by 2 so that the z eliminates again. So this will be plus equation 3 times 2. So equation 3 times 2 gives me 8x plus 2y plus 2z equals 6. So now when I add these two together, I have 10x minus 3y equals 9. So in a way, I have equation 4 and 5 now, okay? And they're both in x and y. So now I can use these two equations and use elimination with them to solve for x and y. Notice that I have a 10x and a 10x with each of these. So what I'm going to do is I'm going to take equation 5 and multiply it by negative 1. So I'm going to add equation 5 multiplied by negative 1. So now I have a negative 10x plus 3y equals negative 9. When I add these together now, my x's are eliminated. I have 7y equals negative 21, so y equals negative 3. I have the first of my three variables calculated now. Now that I have this one, I can substitute the value for y into either 4 or 5 and solve for x. So let's substitute it into 5. So I'll have 10x minus 3 times negative 3 equals 9. This gives me negative 3 times negative 3 is a positive 9. So 10x plus 9 equals 9. I'll subtract 9 from both sides. So 10x equals 0. Divide both sides by 10, so x is equal to 0. So now I have y and x calculated. I can substitute those two values into either one of the original three equations and solve for z. So I think I'll use equation 3 for that. So I've got 4x, so 4 times 0 plus y, which is negative 3, plus z equals 3. So when I simplify that, I've got negative 3 plus z equals 3. So I'll add 3 to both sides. So z equals 6. So my solution is x equals 0, y equals negative 3, and z equals 6. Or I can write that as 0, negative 3, 6 is the solution. Three by three systems can take a full page of work to solve. They're very tricky. A mistake made early on leads to carrying through with a mistake for quite a ways. The steps for doing this are on page 775 of your text. And there are also some more examples there. Here's a challenge for you. So let's try this one and bring your solution to the next class. So first equation is 2x plus 4y plus z equals -1. The second equation is x minus 2y plus 2z equals -4. And the third equation is -3x plus 5y minus 2z equals -7. So try that system using the steps that you see in the textbook, following the example that we just did, and see if you can solve that and bring your solution to class.